Hello and welcome to the second video of demystifying the Azure Firewall. I hope you had a chance to watch the first part of this video, where I have detailed what Azure Firewalls are, how does it compare, what are the limitations, what are the known issues with firewall, as well as your key decision-making process when you try to compare Palo Alto versus Azure Firewall. So hopefully you like that video and hopefully you have watched that video. If not, I would strongly recommend you to watch the first part of this video as well. And now let's dive into the demo of the Azure Firewall. It's going to be very interesting, feature-packed demo in my viewpoint. And let's get into the next agenda one. That what would we be covering in our. So as I was mentioning, that it is going to be an interesting demo where I would probably first make you acquainted how I have created my lab demo as far as my lab is concerned. We will go into the deployment of Azure Firewall. We will look into firewall policy. We'll look into within the policy, would look into the rule collection group, rule collections, rules, all types of different three categories of rule that we will dive into. We will look into threat intelligence, IDPS, and then we'll look into TLS inspection, web categories, policy analytics, and the use cases that I'm going to cover in this demo is first is a VPN connectivity, where we would have an Azure VPN connectivity to the client. That VPN client would be passing through our Azure Firewall. That's the first one. Then we will have a north-south traffic, where we will see the internet ingress traffic as well as internet egress traffic, right? Then we will also see basically east-west traffic here between spoke to spoke. We will see the TLS inspection, both outbound and inbound. Very interesting. As I mentioned in my first video, that Azure Firewall only provides the outbound TLS inspection using the root certificate, the CS certificates, self-signed certificate or the PKI certificate, but inbound TLS inspection I have configured it using application gateway, so that would be very interesting. And you'll also see the diagnostic settings and monitoring in our demo, right? So it's action-packed demo. Let's move into that how the lab is configured. So primarily what we have in my lab, I have one single Azure subscription. And I have put all my resources into a single resource group, which is called as a firewall demo. If you see in the diagram here, my subscription is AZ Entra. This is my demo environment. And I put all my resources into one resource group. I could have done it in a production environment. These could be multiple resource groups distributed between multiple subscriptions, multiple regions, right? So you definitely need to understand that this is a very minimalistic deployment because it incurs cost on myself. Nobody pays for my lab. So I have to be careful to make sure that I optimize the cost for my presentation. Now, having said that, when we talk about firewall deployment, and I'm not going to go into the architectural part of it, that how would you architect your Azure Firewall for your environment, but there are multiple ways, just quickly, that you can have Azure Firewalls deployed in each regions. You can have Azure Firewalls distributed between your internet traffic and basically north-south traffic and east-west traffic, right? Many customers prefer to segregate their internet traffic with the rest of the traffic. You could do that, right? You could also have firewalls based on the department and so on and so forth. So based on your business requirement, business topology, technical requirements, your architecture might differ. But my point here is not to show you the different architectural pieces of Azure Firewall, but to show you the functionality, feature set, and how quick, how simple, how easy it is to manage and deploy, right? That's the overarching goal. So as I said, all resources are in one resource group. I have got 3 VNets configured here. As you see, the center or the hub VNet is firewall, called as a firewall here. I did it long time back, so I didn't want to rename it. But this is my hub, which is what is the firewall VNet. Within the firewall VNet, I have got three subnets. One is the Azure Firewall subnet. You require it with this same naming, right? The name matters here. So that's one. Then I have a gateway subnet that is being used for my VPN gateway. Again, name matters because name has to be exactly the same. And the third one is app gateway subnet. Again, the name matters here, and that is being utilized for the application gateway. And we'll come into what application gateway is being used for. I think I briefly touched it before, right? This is our configuration here. I gave you the IPs. Please keep a close look at the IPs here too, because when we go into the lab and start demonstrating it, it's going to be very important for you to understand and try to make a sense out of it, right? That's the first part. Second part from network perspective is that I explained you this VNet. I have a second VNet, which is called as an app VNet, which has got only one subnet here. I'm not too worried about it, right? I gave you the network ID here, 172.168.0.0. For our firewall VNet, the network ID is 10.0.0/16. Then I have got a third VNet, which is my shared services VNet, which is 172.32.0.0/16. I only have one subnet here too, right? That's our VNet structure. These virtual networks are paired as a hub and spoke topology. So app is paired with firewall VNet, and same with the firewall both ways basically. And the shared services is also paired with firewall VNet, right? So I'm not going to go into the details of the pairing, but that's very straightforward, right? Pretty much from all practical purposes and from understanding perspective, this is a wired connection, right, between in Azure. Now, when we have when we talk about the VNets, we covered the VNets, we covered the subnets, we covered the peering. Now let's talk about the route table, because that is extremely important. So each subnet here, for app subnet, I have a shared services route table, and there are only two routes. One route is for internet traffic, all outbound traffic that goes to the firewall internet interface, which is 10.0.1.4, right? So all internet egress traffic, I'm forcing it to go through my firewall, which is deployed in the firewall subnet here, right? This is my Azure firewall, okay? Now, for my east-west traffic, basically spoke-to-spoke connectivity, because these are three VNets, and as you know, the VNet does not do the transit, right? Their only pairing is only A to B, not A to B to C. So I'm leveraging the firewall here to connect two different spokes here, right? So basically, east-west traffic, have a route here, 172.32.0.4, which is the subnet being used on this side, shared services side, right? And that is also being sent to the internal interface or internal private IP of Azure Firewall. I would not say internal interface, that's the other side, right? So private IP of your Azure Firewall. Likewise, on the other side, other VNet, the shared services VNet and this subnet, we have a route table for shared services. I should have named it differently. This should be app services, basically. I made a mistake here. I forgot to change the name. This is app services, this is shared services route table. I'll show you in the lab quickly. And that route table is again for the east-west traffic from this spoke to this spoke connectivity. 172.168.0.24 is going to the firewall private IP address. Straightforward. Now, similarly, when we are talking about inbound VPN traffic, right? So there is a VPN inbound route table that is again doing the same thing for both VNets, for this VNet and this VNet, 172.32, 172.38. It is again routing it to the firewall private IP, right? Application gateway also has a route table because it needs to force the traffic to go through firewall, right? We'll talk 1 minute that why I'm using application gateway. So for both VNets is sending the traffic to the Palo, and Palo would be sending it to the destination, right? So these are our 4 route tables here. Application gateway here I'm using for the sole purpose of doing SSL inbound inspection. So I have configured application gateway end-to-end encryption. As a result, the SSL offloading happens here, and once it comes in from the application gateway, it is decrypted, send it to the firewall inspect the packet, send it to the endpoint, and then it creates a second encrypted tunnel, right? So that's what it is doing the SSL inbound inspection too. What else? Now, yes. So Azure Firewall are also configured for the diagnostic settings with the log analytic workspace here, EasyLGL01. So all the diagnostic settings are being stored here, all the logs are being stored here. Also from the policy analytics perspective, I'm using a different log analytic workspace here, and this is this one. Then we are using a key vault for keeping the self-signed root certificate for TLS egress inspection. So any traffic that goes out that uses the certificate, that certificate is stored in key vault. Right, so that's pretty much it as far as our lab is concerned. We have got people coming from internet. I have a website running, basically a default IIS website running on this VM, which is 172.32.04, and we're going to test the ingress traffic, the east-west traffic coming through application gateway, right, doing through TLS inspection, going to the firewall, and from firewall it would hit the website. Similarly, we will have a MFA client, VPN client here that is coming from here, coming to the VPN gateway and going inside and making connection to both the environments, right? Both the VNets here, the app side, VM side, and the VM001 side, right? So that covers almost all the possible use cases. As I have already showed, we will also test and demonstrate spoke-to-spoke connectivity. We are showing the VPN connectivity, right? So east-west traffic. We are also seeing north-south traffic coming from application gateway, going to the Palo and coming into our IIS website, right? That is our overarching goal for demonstrating these purposes. We'll go into more in terms of configuring the, threat intelligence, IDPS, web categories, FQDN, all those details would be a part of this demo. So let's just get into the lab. All right, I have logged into my Azure portal. As you can see, let me make it right here. All right, I hope you can see it better now. I just have to adjust the screen. Let me make it slightly bigger so that it is readable. Okay, now let's see here that, as I mentioned, my subscription is Easy Entra. The resource group that I was showing you in my video is Firewall Demo. All my resources is right here, starting from the VNets, right? So let's look into the virtual networks first, and I'll show you what it is. So if I go to the virtual networks, these are the 3 virtual networks that I showed you in the video. If I look into the firewall here, so real quick, because this is not a Azure firewall deployment, but it would be required in any case, right? So if you look into here, the peering, the firewall is paired with the shared services VNet, and also it is connected to the app firewall, right? So this is the hub, and it is connected to the both spokes. Because I have the VNet, I have the VPN connection here, and I have a VPN gateway. That means when I configure the VNet here, I'm using the virtual network gateway as a router or server so that my VPN clients can actually connect into my other spokes. Otherwise, it will not work, right? So this is on this side, and if I show you on the shared services side, the peering, same thing would be, it will be using the remote virtual network gateway router, right? Otherwise, my VPN clients would not work, right? So this is very simple. The peering is clear. Now, if I go and show you the route tables, so this was the mistake I was showing in the video. So if you look into the app, the routing table here, 2 routes pointing into the internal interface of my Azure Firewall. This is shared services for the east-west traffic, and that is for to go to 172.32. That is the other VNet. It is again hitting to 10.0.14. The subnet it is connected to is the app subnet, which is in the app router here, and the other VNet that I showed you. Similarly for the shared services, right? So if you see the routes here, these are the route for to go the other side, very similar, which is the same thing that I showed you in the visual. On the VPN inbound and AGWI is pretty much the same routes here, right? So it's going both VNet, so shared services VNet and app VNet here, and that's my routing table, right? Similarly on the AGWI, which is my route table for application gateway. And the route here is for 172.32.0.24, which is what is my application is sitting there, right? That's pretty much it. That's the only thing that I need here. All right, so this is all good here. Now once I have showed you this, so next thing is I'm going to show you, I've already deployed the Azure Firewall, but let's just quickly go and show you how simple and how easy it is to deploy a Azure Firewall. Or before I do that, let me just show you what the infrastructure is, and then we can go into the deployment, right? So let's look into firewall. That's my AZFW101 firewall, single public IP here. Right? That's my IP address that I showed you in the diagram, the private IP address. This is my public IP address. I only publishing one site. By the way, this public IP that is configured during the deployment cannot be removed, cannot be deleted. You may add more public IP addresses here, as I show you here. Very simple to add more public IPs. These public IPs should be created in the same resource group where the firewall is, right? So that's pretty much it. Diagnostic settings, as I will show you here, is already pre-configured to the log analytic workspace, and for the firewall policy setting I have configured it to the other log analytic space, and these are all my diagnostic settings going there. So very simple, very straightforward deployment, right? Now we will also go into the firewall manager. And in this case, firewall manager, you will see the summary here. I am not using virtual hub here. I am not going to be discussing the virtual WAN here. That's a separate discussion topic, so we're not going to go into that, right? And we are already covering here 3 VNets that we have, right? I don't know why it's not showing me the application gateway here. Now, if you look into the firewall manager, Azure firewall policies, I have deployed one single firewall policy. We'll see it once we deploy, and then we'll go into more details here. The virtual networks, if you see very quickly here, this is the firewall deployed in this firewall VNet, and both the firewall are connecting to a virtual hub, right? That's how it will show up once you connect those VNets through a VNet which already has a firewall, right? Straightforward, simple, easy. Now let's go and look into a deployment scenario of a firewall. So let me do quickly a couple of things. All right, so let's see the deployment of an Azure firewall, and as I told you, it's pretty quick and simple and straightforward. Let's try to see if I'm going to create a firewall here. I created a new resource group just for this purpose, and I'm not going to deploy it. I'm just going to show you how quick and how simple it is. And I'm going to deploy an East US availability zone. This is what I was talking about, folks, that this is an additional feature that you have from the high availability perspective. I can have all the zones created here, right? Now, as I mentioned earlier in my last video, that if you use a premium, then you can only use the firewall policy. If I change it to standard, then I can choose the firewall rules or basic, right? But right now, if I want to use premium, I would be forced to use firewall policy. And as I already showed you in my earlier video, there is a price tag attached to it based on how you use it. If you attach to a single firewall, then you have to pay $0 But if you attach the same firewall policy to multiple firewalls, depending on how you do that, watch my video, then you would incur $100 per firewall policy per region, right? So it's straightforward. Now, firewall policy, as I said, I already have a firewall policy. I could attach it and I would start paying up for this policy again. I don't want to do this, so I can create a new policy here, add new, and I can call it as a new just for this, right? And you have the option for all three types of policies, which prices I have already shared with you in my earlier video, right? Now, from the firewall network perspective, you can create new. It gives you the option. I already created it, so I'm going to pick up that VNet here, new. It already had the requirement for that was that you should have the subnet already with the same name. If you do not have the name, then it's not going to let you do that, right? Now you need to create a public IP. I can create a new public IP here. And rest is very simple. I don't need to do that. And review and create. This is it. This is it when you deploy a firewall, right? And that's my point. If you remember my first video, I said it very emphatically, and it proves my point that deployment of this Azure firewall is so quick and simple. Anybody can do it. You don't need high skilled other third-party engineers to deploy a firewall. This is as simple as that. You could deploy it in a GUI, you could deploy it through CLI, PowerShell, ARM template, Terraform, whatever you like. So this gives you the ease, right? Ease of deployment. I just showed you how simple and how easy it is, right? Once it is done, probably it will take about 10-15 minutes. I don't have to do that. Then you're good to go and start configuring it, right? Now, configuration of Azure Firewall is, again, from the base firewall perspective, is pretty simple. Look at what you need to do. Obviously, access control IAM, if you need to give somebody access, I'm not going to go into those details. Public IP configuration, it already had a public IP configuration. Depending on how many inbound traffic endpoints you have, let's say you want to publish 10 APIs and 10 websites or whatnot, and RDP or blah, blah, blah. You figure it out how many of them you need it, you may add it here, right? That many number of public IP. You can get up to 250 public IPs here. Having said that, in one of my other deployment, I only use a single public IP here, or maybe 4 or 5 in a very large complex environment, and I use in the background application gateway to use the remaining piece of routing, right? I use a wildcard certificate, and I just was able to use application gateway not to open up multiple public IPs on my firewall. You have that option available. At some point, I will show you that diagram where I did that for a lot of Kubernetes cluster, right? So I did not expose tons of public IPs for each of the Kubernetes sites that we were deploying, right? That's a very interesting configuration too, and I'll explain you sometime. That's doable. But for the simplicity sake perspective here, you could add as many public IP up to 250 on this interface. Very simple to do that. Obviously, you pay for public IP configuration, right? No free lunch here, guys. So keep in mind, add public IP, you add the cost for the public IP too, and then if you do the DDoS on top of it, you also pay for the DDoS services, right? Now, you don't have to do anything except for adding the public IPs here, depending on what you need. Diagnostic setting is a very simple configuration, right? You could add diagnostic setting. It gives you all these options here. You can do all logs, right? And then you can say here, where do you put a name here? And then you can send it to Log Analytic Workspace, storage account, Event Hub, or a partner solution. How simple is that? If I just select Log Analytic Space here, right, I have got this subscription, I have got Log Analytic Space this, or I can have this, and I can add a diagnostic or resources specific. This is important, folks. I would recommend, I think I made a mistake earlier that when I did it, I didn't realize it. It should be resources specific. Then it creates a resource specific table, and which is the right way to do that, right? If I show you here, right, so you can also see it here. I forgot to mention one point when we were deploying the firewall. I had to go back one more time. I'll show you there. But this is what it is, right? That's the only configuration. Now, I don't know whether I can change it here now or not. Let me see. Oh, I can. Perfect. All right. So this is the logs. This is where the logs query would start, right? And it gives you plenty of built-in log queries that you can run it. We'll come back here once I show you the other stuff and we generate some more data here. Okay. That's all you need to do from the firewall configuration perspective, right? Depending on that, how many public IP addresses you need to use. And it is proving my point, which I shared with you in my slide video number 1, that it is the simplistic, easiest way of deploying a firewall. Quickest, simplest, easiest, fastest, right? And that's here. Seeing is believing. Nothing you need to do. You have the metrics here. You can look into the metrics very easily, right? And you have got this metric criteria, and we will see in the policy analytics down the road as well, right? So this is no rocket science, and many of you who have been working in Azure are very familiar to this blade. You have already seen it, right? Yeah, so as I forgot to mention something while we were trying to, while I was trying to show you the deployment, there is an option for force tunneling here that we can do, and it is self-explanatory. Enable force tunneling to create an additional subnet for firewall management traffic, and this subnet will have a direct access to the internet. It will also give it a public IP on that interface, so it will have an access, right? So you could choose to do that. I have decided not to do that. It's up to us whether we want to create that or not. I don't see anything, especially in my use case, to do that, so I didn't do that. With that, let's just get into the firewall policy. Remember, when we created this firewall, it asked us to create a firewall policy. We created a firewall policy, and let's look into the firewall policy. So this is the firewall policy that I created while I was deploying the firewall. It is already attached to this firewall, so no additional work required. And you already know the pricing part of the firewall policy too. Now you can have a parent policy and then you can have a child policy structure. In this simplistic environment, we don't want to do that, right? If you do that parent policy, there should not be any parent policy here. But you have an option to choose parent policy once you do that, and you can create child policy underneath it. Now, rule collection. Now, we have 3 different types of rule in the policy. One is the DNet rule, second is the network rule, and third is the application rule. Each of them is self-explanatory, right? When we start looking into the destination network address translation, many of you are familiar with destination network address translation, but let me try to explain you what it means, right? So for an example, if I open my Visio back again, so in this scenario, we are hosting a website, an IIS website on this VM, which is running 172.32.0.4. So just to explain you the destination address translation. But this is a private IP address. So if I want to access this website from my laptop or from somewhere from the internet, I can't hit it, right? Because this is internal network. So how do I do that? So I would send my traffic to my public interface. In this case, I would be sending the traffic to my app gateway. App gateway, I should not give you this example, this would confuse you. Let's say I'm running an RDP services on this, right? And I want to connect this RDP from outside my environment, from my public network. How do I do that? This is not exposed to the external world. So, oops. So, once. So what we do here is that we have a public IP on our firewall. I would send my public IP traffic to 10.0.14 either through the DNS or directly, oh sorry, this 20.85.137.98, which is my public IP address. And that public IP address could be translated as a destination network address translation to this IP 172.32.0.4. And on the same port. So when I do the destination network address translation, I need to know few things. Where I am receiving the traffic. So in this case, I am receiving my RDP traffic on 2085.137.98, correct? And what port you would be receiving the traffic? Oh, I would be RDP traffic, I would be receiving on 3389. And then where would I be sending the traffic to? Where would I be translating to? Oh, I would be sending that traffic to my endpoint 172.32.0.4, which is my RDP server. And which port you will be sending to? Oh, same port 3389. That's all it is, right? That is destination network address translation. It could be RDP, it could be an API, it could be a web service, whatever, right? And you could send the traffic here. Now, why I did not give you the example of this application gateway, because if I have an inbound SSL traffic coming in, HTTPS traffic, whether for APIs or web services, I want to do a TLS inspection. So I don't want to send a encrypted traffic on my public interface because my firewall would not have any capability to inspect that packet, deep packet inspection, which is IDPS, right? Intrusion detection and protection system. So if I'm sending an HTTPS traffic directly to firewall, I'm not able to leverage the premium feature of my firewall, next gen feature of my firewall, which is intrusion detection protection system. So that's the reason what I did here is that all my HTTPS inbound traffic, I'm sending it to the application gateway, which has the capability to provide end-to-end encryption. And here I offload the SSL encryption. It can offload it and then send the traffic that gets inspected. And once it is hitting there, then it can create a secure IPsec tunnel, right? So this is the way I'm going to send all HTTPS traffic through application gateway to take the advantage of inbound TLS inspection. Otherwise, if I send it directly, I'm not able to use TLS inspection. So I have explained you both scenarios here, right? Going back into our firewall policies here, right? So if I go back here, so this is our DNet, right? Now for the network rule collection, there is no network address translation requirement. You are going from point A to point B. Basically, you are connecting from east-west traffic, right? You're getting from one spoke to another spoke. And that's where you would configure network rule collection. Or if you just want to go to outside, right, internet, and then you want to hit it. That's one scenario. Now, if it is an application and you need to do an outbound SSL inspection, that's where you would use the application rule collection group. So let's look into each of them so that we can understand. So the DNet rule. So I originally created the second rule because I was originally not using the application gateway. So don't worry about this. This needs to be deleted. But for RDP that I was discussing to you, it's very straightforward, right? So you have a default rule collection group. There is a rule collection, which is demo, and then there is a rule, which is RDP, right? So this is my default rule collection group with priority 100. Each rule collection group has to be given priority. Well, I'll show you right in a second. And between 100 to 65,000. And each collection also needs to get in priority. And priority, the least the priority is that gets applied first. So when we are talking about these firewall rules comes only in action if the traffic has passed through threat intelligence and IDPS. If the traffic is already not applicable, if the traffic is already in a deny mode from threat intelligence or IDPS perspective, these rules will not even hit, right? The traffic will not even hit the rules. So let's assume that the inbound traffic has already passed the threat intelligence, already passed the IDPS, then it will hit the DNet rule, then network rule, then application rule. So this is the order, right? Now each collection group, rule collection group has a priority. Each collection has a priority. So let's just show you that when I try to create rule collection group, these are the default one. This is automatically created in each policy. So I didn't modify, I didn't change it. But if you like, you can add a new rule collection group. And you can call it, for an example, XYZ. Now you need to give a value between 100 to 65,000. Now you don't want to start with 100 because 100 is the lowest priority. So you might want to start with a higher number. So maybe you want to start with 10,000, right? And just add it. Now you have a new rule collection group created. Within the rule collection group, then you will create a basically a rule collection. So if I go to this here, and I can add a rule collection, and I can call as new. I'm not going to do that, right? So rule collection type is network or application or DNet. So for example, it's a DNet. Again, I have to define a priority here, and let's say I define the priority here 1000. Right? Now this is rule collection action, rule collection group. Now this rule collection group, if you have created more, then you will see it. But this is the DNet rule, so you can pick up this guy, right? A rule collection with this priority already exists, right? Now you can create a rule. So now you have got rule collection, you have a rule collection group here, you have the rule collection, and you have the rule. That's the default architecture, right? And that's the priority here. So I'm not doing it. I was just showing you that how simple it is. So if I can prove my point here, in this one, that's the DNet rule. I have got these two. I can show you the RDP working momentarily. Let me close it here first so that I can show you. Right, so this is my VM and where it is connecting, or let's say we need to create a new rule for DNet rule, right? We are talking about new rule. So first you have to pick up here, right? It's already created, so I can see that, but I'm just gonna do, let's say XYZ, right? This rule collection has no word, so it's not gonna work because I don't have a rule collection created. So let's leave it the way it is. So rule collection, I have a demo. That's what it is. I can create a new rule called as an RDP. Now IP address or IP group. So if you have got multiple IP addresses that your traffic needs to be allowed, this is allow list or this is the white list. Right now I'm leaving it to IP address, right? And I can say I'm going to allow from everywhere, or I can pick up some IP addresses or some CIDRs that I need to allow this traffic to come in. And where is my destination IP address? This is my firewall IP address. So if I go back, where my traffic is coming? Oh, no. So public IP. I only have one IP. So if you have multiple IPs, you might need to choose the right IP that can be used for that service. But destination IP address would be the public IP that you use. It picked it up. The protocol, TCP. I'm doing RDP here, right? So I can be fine with TCP. The destination port, where would I receive the traffic? 3389. Translated type is IP address or FQDN. Now, if you have the FQDN, that FQDN should be resolvable by this firewall. No, it needs no brain. If you cannot, then you probably want to configure your DNS or DNS proxy here that we can discuss. But to simplify here, the IP address and where it is going to go, I'm going to send it to 172.38.0.4. Now, here is the challenge. This IP is already doing an RDP destination to another VM, right? So let me show you. So we are already RDPing with this IP here. With this IP, where I'm already doing RDP here. So if I try to do RDP using the same public IP to this is not going to work. So I need to add one more IP to let it happen. You got my point? That means I need to add one more public IP to accommodate my requirement to connect to this VM, right? So that is the whole point. Now, going back to the firewall rule, and where do you translate it? Where do you want to see it? 3389, right? How simple is that? Is it not simple and intuitive and user-friendly, which I mentioned in my first video team? I mean, am I making it too simple? I think this is simple. You need to know where you are going to get traffic, what port you're going to receive the traffic, which IP address you're going to send the traffic, which port you're going to send the traffic. That's it. You're good to go. And you don't need to create anything else besides this to make this work, right? Let me show you this rule is working or not, right? Basically, I need to connect to this IP to show you the RDP working here, and it is going to pass through this DNet rule. So if I just do the MSTC, and I can bring this window here, I'm connected to 20.85.137.98, boom, connect, and here you go. I have already an Active Directory. Voila, right? Seeing is believing. How simple is that, team? This is what the core point that I'm trying to make. How simple was that to configure a RDP connection using Azure Firewall and using the DNet rule? Now, if you have worked on other side, then you will know how complex is it, right? I'm not going to go that route. I could have shown you that other route too, but this is so simple. Had it been a Palo Alto, I need to make sure that I have an Azure load balancer, front-end Azure load balancer public IP. I need to make sure that the health pro from Azure load balancer to my firewall is working. Then I need to send from Azure load balancer to the untrust interface of Palo Alto on a different port, because I'm using the one, I'm not using multiple IP on my firewall, right? So I will be receiving on untrust traffic from multiple IPs, multiple ports. So I need to engineer it, architect it properly. So the traffic comes on for RDP on 3389 on my Palo Alto for Azure load balancer. Now I need to translate it to go to an XYZ port, an unused port on the untrust interface. Let's say I'm going to send it to 16,000. Once the traffic goes to the 16,000 on untrust interface, Palo receives the traffic based on if health probe is good. Then I am going to say, okay, if you receive traffic on my untrust interface on 16,000 port, then from untrust you send it to the trust interface, right? Because trust interface is connected to my internal network, private network. Okay, now private network, once I get to the trust, then I need to do the DNet, and I say, okay, now I need to do the destination network address transition. By the way, I need to add also my security profile, policies, pre-policy. It gets complicated. Here, it is so straightforward. You don't have to worry about load balancer, health probe, natting from load balancer to the Palo Alto, then doing Palo Alto rules and making sure that Palo Alto's health probe is Microsoft headache. You just simplified it a whole lot just by knowing where you would receive the traffic, what port you would receive the traffic on your firewall, where you would translate it, and which port you need to translate to. I can't think of anything simpler than this. Maybe I feel simpler. I don't know how you feel it. Please give your comments in your feedback. But I personally feel this is very straightforward, right? Now, since I have proven this here, now we also go to the network rule, right? For an example, in the network rule, the same story here, right? You have a rule collection group, which is what is a default network rule collection group that has a priority of with a priority of 200. I have several I have got the rule collection as demo here, right? And I have got different rules here. So first rule I have is, let's see here, that is from source is 172.168.0.0.24, which is the app VNet, and then I'm sending it to 172.32.0.0, which is a shared services VNet, right? Now I'm allowing all the traffic. Basically, I'm giving full spoke-to-spoke connectivity. Now I could be selective here, but I could select only few ports here. I could select few specific IPs, but just to make it easier for us to understand, right? If it's a wide open connectivity between these two VNets, supposedly this would be a different structure, right? Supposedly the first VNet I was using for an app tier or a web tier, and the second VNet I was using for an hypothetically for a database tier. Then perhaps I would not do that. I would pick up the right app server, right? Instead of IP address, the whole CIDR, and I would pick up the destination IP, and I would allow only the required ports. So this is where the easy part comes in. But to you, to do this is pretty straightforward, right? So that means my 172.32.0.024, which is my VM, should be able to connect to the VMs in 172.38.04 on every single port. So let's see it, right? So if I go to this VM, so this is 172.32.0.4, right? This machine. Can it ping to 38.0.4, which is the other VM? Yes, it can. Can it do the DNS lookup here, right? DNS lookup. And I don't remember the app VM dot easy intra dot info. Maybe I have 01, I forgot the name. Anyhow, it can do the DNS query here too, right? Once I know the actual VM name. If I go from here and do the RDP to that machine using the network rule, passing it through my firewall, can I do that? 38.04? Yes, I can do that, right? Can I go to the share from this machine to my another spoke? Yes, I can, right? So that proves the point that I have simple, very easy to connect spoke to spoke, whether you allow the full CIDR, whether you allow the specific IP, whether you allow the IP port, right? Now let's look into another rule that I created just for demonstration. I created a VPN in traffic here, right? That means I have a VPN running in my Azure VPN gateway, and I'm able to connect from my laptop to this VPN and going into my network, right? And I should be able to connect, right? So what it is saying that if I look here, I added this rule. So VPN in, source is IP address. My source is the CIDR of my firewall VNet, which is hub VNet, because that's where my VPN gateway is. And I'm also allowing 172.40, which is the IP addresses that I'm assigning to my VPN client, right? And I'm allowing everything to both my spokes, 172.38, 172.32. Let's see it, what I mean. So if I go here, what I'm looking into, not a what VPN gateway. So this is my VPN gateway. Now, if you look into the point to site configuration, right? This is the IP address pool that I am giving. This is what I'm allowing in the firewall, open VPN SSL, Active Directory authentication with MFA. Very easy to do that. I have actually another video for point to site migration, point to site VPN on my channel, which I did it through GUI, and I used the certificate. You could use the certificate here too, right? Instead of OpenVPN, you could use IKE v2 and OpenSSL, but for this purpose I'm just using OpenVPN SSL, right? So this is easy. And if I show you that whether I can connect through MFA and right, I'm connected because I'm already authenticated to Azure Active Directory, so it didn't even ask me. It has all the routes. Now if I go from here, but directly from my machine, and I try to do the RDP, hopefully I should be able to connect to that VM here. Do I have it? I can connect to 32 for sure because I might have connected, but let's try 38. Here you go. So basically, now my VPN traffic is coming to the VPN gateway, passing through my Azure Firewall, going to my spoke. And how much time it took me to do this? How much time it took me to do this? Pretty much deploying the Azure VPN gateway, right? Pretty much deploying the Azure VPN gateway. VPN gateway takes about probably about 25 minutes to deploy. That's what the VPN gateway takes time. And then you just configure it, maybe another 10 minutes. And my firewall rule took me another 5 minutes. Maybe altogether give and take about half an hour to 35 minutes to allow your VPN connection to your environment. Is it not simple? Then what is the definition of simple if it's not simple? Right? This is all what I talked about in my first video. So this is the example. Right? Going back to the firewall policy. This is so intuitive. The word intuitive actually resonates every single time you work on the Azure Firewall. Let's look at the application, right? Now, this is where I have configured it to SSL inspection. This is TLS inspection basically for the outbound traffic, and it is very simple to do it here too. So basically, if you go to the TLS inspection here, this is only for egress traffic. First is that you have to enable it, right? Secondly, you need a managed identity. This is a user managed identity, not a firewall system managed identity. So FW cert, this is what I created. Now, when you do it first time, it would have the option to create it new, or you could use your own. So you could use if you already have a PKI environment in your Azure, you could create a subordinate certificate, and you can pull the certificate keys out of it and certificate out of it, deploy it, and you're good to go. You definitely need a key vault, and your key vault, you need to give access to this managed user identity, right? This is important. Again, it's not a rocket science, it's a pretty straightforward. I have a key vault. I have given this managed identity the rights, either through access policy or key vault RBAC, whatever you prefer. Once you have given him the rights, you have a key vault, you have the certificate that you have, right? It could be, this is a self-signed certificate for this demo, but you could have a PKI based certificate too. And then you can use the application rules and you can define the URL or FQDN based. So this is where the premium feature that I mentioned about URL versus FQDN, right? So let's look into. So when I see the URL is actually domain name / a virtual directory name, that's a URL. If it's just a pure domain name, for an example, this is an FQDN. Bing.com, www.bing.com is domain name, right? While google.com /webhp and google.com, let me edit it to show you. So Google source type is IP address. This source IP address is my Azure source IP address, right? Not external IP address. So I'm saying anything from my Azure can go to Google, and destination type is URL, FQDN tag, or web categories. This is interesting, right? So for example, if I choose URL, then URL, I have a virtual directory after it, right? After the domain name. But if the implication here is that if I try to go to anything else except these two sites, I would be denied. So let me show you what it means, right? So let me go to the VM here and let me open browser, and let me just try to go, come on, https www.google.com. because I may have to make it bigger for you guys to read it. Right? Action, correct? Now, if I do this here instead of this, because I allowed the URL, not the FQDN, voila, right? I can hit the web HP and search site fine, but I cannot go to the google.com because I only allowed the URL here. By the way, you also want to see what the certificate is being used here. Oops. And who is issuing the certificate here? That means I'm doing an outbound SSL inspection team here, right? I'm doing an outbound SSL inspection using the Azure Firewall, the self-signed certificate that I deployed on my firewall. Is it not that cool? That means every single transaction that's happening now is going through TLS inspection, right? And I told you that I'll show you. Now let's see another example here. For an example, the Bing, I'm doing the FQDN here, right? So let's edit this, right? So Bing FQDN, www.bing.com. And you have to define, and TLS inspection is checked. This box would be grayed out if you have not configured a TLS inspection here, right? Very simple to do that. Easy. Now, the implication here, let's look into I'm lying bing.com and www.bing.com, right? So that means I would have no problem. If I go here, Google search, I will give you one example here. Let's do this, right? If I try to click this, it's going to deny because that link is not going to work. We have not allowed it. Or let's see here. It's not going anywhere because those URLs are not allowed. On the other hand, let's go to the Bing www.https right? And I can actually go here bing.com or www.bing.com or bing.com, and whatever is the other option on this site, I can pretty much use it, right? But as soon as I get out of here and go to msn.com, this is not going to make it work. So I have full URL based filtering. I didn't do anything else except for allowing the FQDN. I also have a malicious site that I configured here, but that is to test the IDPS and IDPS as well as threat intelligence here, that I allowed to make sure that I can hit some traffic there, right? So team, if you look into the different types of rules, I have detailed you, I have shown you in action the DNet rules by showing you the RDP connection. I have shown you the network rule between spoke-to-spoke connectivity, easy to do that. I have also shown you how simple and easy it is to use the network rules from perspective of from spoke-to-spoke connectivity. And I also want to show you this, right? The DNS out, I configure it because my machine here, this is an Active Directory domain controller, so it's running its own DNS, right? So in this DNS needs to go outside to get the outside results, right? So on the root hints, unless I allow the traffic 172.32, this rule here, it's not gonna find any external URLs, right? So That's how I'm able to go to Google or whatever, right? Amazon.com or whatever, because it allows me. So if I go here, it's too small, but let me show you. See, it is resolving. Let me make it font. Right? It is able to resolve because I'm allowing it through the network, this rule here. Correct? And then I can also show you this app gateway, a TLS inspection coming in here. So I have a app gateway configured here. Bring it up. So let me show you quickly TLS inspection, and I should be able to go to application gateway. And my application gateway, the front-end public IP address is this guy, 20.115.109.121, right? And I have configured it. The backend pool is my internal private IP address. But guess what? I'm routing it through firewall, right? I'm routing the traffic through firewall, and I have got this certificate here on for HTTPS. Cool, and you can close it. I have got front-end IP configuration that I already showed you. I don't have any private. This is my listener, right? On 443, I have a health probe, and it should be working. So if I go to my laptop here and use PowerShell, one second. And I do ns lookup www.azintra.info. So it's getting me 20.115.109.221 teams. And if you want to check it one more time, the front-end IP configuration is 21.5, right? Let's bring it side by side. 21.115.109.121, right? Now let's see whether this makes sense or not, this works with this rule or not. So let's go here. Here you go. So this is going through SSL inspection via, I'm going to close it. This is going through SSL inspection via Azure Firewall. Let me also show you, I think I showed you the route, but all the traffic is going through application gateway. No, application gateway through Azure Firewall, right? That proves the point. Now, so we have shown you all three different types of rule effectively. DNS, you could use the Azure default DNS, right? Or you could enable your own DNS. You can use default or you can use custom. For an example, you could do custom here, and it will start pointing to the Azure, so that you can use private DNS zone, for an example, right? So this is straightforward. It doesn't require a lot of thinking. It's very, very simple. You could do a DNS proxy here to transfer as well. I'm not going to do that. I'm going to cancel it, discard changes, disable, right? Discard changes. I'm going to close it. I don't need it, but this is so simple. Threat intelligence, right? We discussed that. Say alert and deny. You have only two options: disabled, alert only, alert and deny. And you can exclude certain IP addresses if you want to, right? Or certain FQDNs. Straightforward. I have already showed you the TLS inspection here. Let's look at the IDPS, right? You have got options, the same option that you have for threat intelligence: alert, alert, and deny. Now, this is important when I talk about IPS, right? This has to be enabled and it has to be in the alert mode. So if I go here and edit rules, it should be alert and deny, apply. Then you are gonna work here, right? So there are so many of them. There are almost how many? 65,750. You need to look into and pick it up if you don't want any of them, but this is what you need to enable it. And then on top of it, the private IP ranges, right? Private IP ranges, traffic is inbound or out. By default, only ranges this, as all of you are private IP addresses. You can modify this if you want to do that, right? You can change and you uncheck it, and you can add additional IP addresses that you want to add into this range. For an example, I can add 172.38.32 here that I'm using, right? This is, and you can also have a bypass list. IDPS will not traffic, so if you want to bypass certain things, you can also do that, right? Now, oops. The secure SNAT here, right? This is also, you have this configuration. This is advanced feature that network traffic source network address translation. It is self-explanatory. Does not SNAT if the address destination is a private range, right? I use it in my environment, right? So if I don't want to do that for all IP addresses except INA RFC in 1918, or you could do always, or you could use for all particular IP addresses, right? Now I thought I should also show you the web categories also you can configure, and you can add it here. This is an advanced feature too. I think one thing I thought I should show you here. Let me give you 1 second. So in the network rules, you could also use, let me cancel it here. You could also go from IP addresses to the service tag, right? And you can use already built-in service tags that my Azure has, plenty of them, and you can use the services based on that. So you could simplify your firewall rules as well. Difficulties in my recording, so and I deleted my environment. So just want to show you that there is a possibility of running the log analytics. Basically, all the diagnostic settings that we configured, there are built-in capabilities and built-in queries that you could execute it. Not very intuitive. If you know the log analytics query, then it will help. But it will give you the report and it will show you what's happening in the environment against each type of rule, whether it is application rule, network rule, threat intelligence, IDPS, even of the firewall decisions. That all you can see it here, right? So that's available to us. Unfortunately, my recording got messed up, and I have deleted my environment already, so I can't go back there. My sincere apologies there. In addition to optimize cost during your testing phase, because if you want to save money while in your testing phase, you can stop and deallocate your firewall and bring it back. Very simple command I'm showing you right here, and you can definitely leverage that. Apologies once again for the last part of my recording get messed up, so sorry about that. But I think I have covered almost every area besides the FQDN tag that I wanted to show you, but as the environment is deleted, can't do it. This concludes this presentation, and I hope this helps you. I hope it proves the point of simplicity, ease of deployment, scalability, all the features that I mentioned in video 1, and it proves the point that it is simple, easy to deploy, manage, and operate. And I hope it helps, right? Thank you again. Thank you all of you very, very much, and have a great evening or great day in whichever part of the world you are. Please do provide your feedback. Bye-bye.